Hey everyone, let me just. All right. Hey everyone, I'm Elvira, and I will be teaching you guys Intro to Python today. Just give everyone a second to get it. All right. So the first thing we're going to start off with today is comments. So in Python, occasionally maybe you'll want to mark up your code with a comment to note something down or give the purpose of a line of code, anything like that. You have a single line comment that starts just with a hashtag. You just put anything on that line that's a comment. Or you can have a multi-line comment in which you have multiple lines that are part of a comment and you surround them by either single quotes, 3 single quotes, or 3 double quotes. And the next thing that we're going to start with is print statements. So you just have this print followed by parentheses in which we have some set of characters surrounded by double quotes or single quotes. That's just printing a string. You can also print different strings together by separating them with a comma. If you separate different strings with a comma, then you will get a message that's separated by spaces. So here we have 3 strings, message with arguments. It's going to print out message with arguments, but it's going to separate them with spaces where the commas were. There's also string concatenation, where we have 3 strings and we're connecting them with a plus sign. This is literally combining those strings together into one. It's not adding a space like the comma is. So we have message with concatenation. And here we're going to go over our data types. So the first one we talked about was strings. So strings are a set of characters. You can't use so if you have numerical characters inside, they can't be used in math calculations. They're literally just characters on a screen. So you can surround them with double quotes or single quotes. For example, we have this variable called name equals, which is my name, Elvira. I started by single quotes, but I could have used double quotes too. I can't use this in any sort of math calculation. Floats and integers are our 2 math types. Floats contain decimal numbers, so write them with a decimal point. For example, weight equals 94.6. You can have integers, which are just whole numbers. You write them without a decimal point, so age is 16. And we also have another type that's different from these 3. It's called Booleans. It's just supposed to address the state of a condition. So it can be 2 things. It can be true or it can be false. So I could set a variable called is working, and I could say false. And variables, like the ones that we showed examples of before, can have names consisting of any character. However, they can't be only numbers, and they can be all the data types that we just discussed. Now for variable naming and input. So variables are named in Python with snake case. So that means that they're all lowercase and the words are separated by underscores. For example, we have this word mood today. It's all lowercase. The 2 words are separated by underscore. Constants I didn't give an example of, but there are some values in Python that maybe you want to keep constant, you don't want to change them. And to signify that, we put the word in all caps. For example, if I had, let's say I want to make a variable for some amount of digits of pi, I would say pi in all caps equals whatever I want it to equal. Then here we are also going to be introduced to the input function. The input function is just input with parentheses, and inside our parentheses we have a string that goes inside. That string is sort of like a prompt that asks the user what to input. So when I put mood today equals input, how are you feeling today? Our console is going to print out, how are you feeling today? And it's that the user will be able to type something right after it, and whatever they type is going to be stored inside of this variable. and then this line would just print out whatever they typed in. So this is useful when you want to take the user's input and use that in your code. Then we have our types of errors. Occasionally, what you'll have to be able to do is look at an error message in your console and be able to figure out what exactly is wrong with your code. So syntax errors they occur during the console's interpretation of the code. They're usually because of things like misspelling, incorrect or unknown variable names, missing parentheses, just stuff that's wrong with, like, it's usually really small things. They're not really concept errors, they're just things missing inside of your syntax, like just your spelling and your parentheses, stuff like that, or even a missing period, something like that. Runtime errors, they occur while the console is trying to run the code. It causes shutdown or incorrect behavior. So this is where your code, the computer is listening to what you're saying and it's able to run, but it's not functioning as you want it to. So we can avoid this with if-else and exception handling. This could also be caused by division by zero or calling non-existent methods. Then casting is where we have all those data types that we talked about before, string, int, float, and we want to be able to change between those types. So if I have any variable x and I surround it by this function float x, I could turn it into a float. Obviously that type has to be numeric, has to be an integer. Otherwise it's not going to work. You can't turn a string into a float, but you can turn an integer into a float. Same thing with this int function. You can turn variable x into an integer. It should be a numeric type already. Booleans also work too, I think, but use a numeric type inside of these. Then stir x just turns x into a string. Here you can put integers and floats, but here you wouldn't be able to put strings. That wouldn't work. Then when you're converting a string into a numeric type, if the string contains letters, there'll be an error. So when I said you can't put strings in here, you can't put strings that have letters. You can put strings that have numbers though. So if I had a string, for example, I had the number 1 surrounded by quotes, I could turn that into a float or an integer, but I can't turn the letter A into a float or integer. When I have type, if I use this type function, I can determine the type of x. So let's say I had the number 2, and I want to figure out if that's a string, integer, or float. This will be able to help me do that. And now we have our operands. So coding sometimes involves some math, and some of the symbols aren't what you usually would expect. We have our addition and subtraction, which are pretty self-explanatory. Our multiplication, if you weren't familiar, we can't use x for multiplication. We're going to use the asterisk. We have a modulus, which you may or may not be familiar with. What this does is it helps you find the remainder. So let's say I had something like 9 divided by 2. That obviously doesn't divide equally, right? So we want to be able to find the remainder of that with this modulus. So 9 divided by 2 would have a remainder of 1. So what we would get from this function would be the number 1. Floating point division, it would give you the decimal answer to a division problem. So if I divide something, any two numbers, like 2 divided by 3, it's going to give me the decimal answer. However, if I did that with this floor division, which is these 2 slashes, we would return an integer that's as close as we can get to the actual answer. So before in the modulus we did 9 divided by 2. The closest thing to 9 divided by 2 and as a whole number that we could get is 4, because 8 divided by 2 is 4. So this would return 4. It wouldn't return 4 point something like you would expect. This would return 4 point something. If I did 9 divided by 2 here, I would get 4 point something. Now, we also have this exponent function where we can do x raised to the power of y with this notation right here. So I could do 2 star star 3, and that would be 2 raised to 3, which is 8. Oh, sorry, I didn't see that you were raising your hand. Manuel, did you have a question? Just let me know in the chat if you have any questions at any time. Did not see that you were raising your hand before. All right, just let me know. Then now we're on to logic operators. And these are what we use in our if statements. So I will go over the if statements. I think I might have missed. I think the if statements are later in this. But before we start with the if statements, we're going to do and, or, and not. So let's say I have two conditions here. I have condition 1 and condition 2. I want to see if both of those are true. If I want to see if both of those are true, then I can use the and. If I want to see if one of them, at least one of them is true, I use or. And if I want to return the opposite of a condition, I return this, I put a not in front of it. So I put them inside of a string so that they would print, I cast them to string because you need to cast Booleans to string to print them out. You need to cast anything that you want to print out, so just remember that. Condition 1, let's say condition 1 is true and condition 2 is false. Since condition 2 is false, this and statement would evaluate to be false because I want both of these to be true. If condition 1 was true and condition 2 is true, then the and works and the statement would print out true. If I have a condition that is true and a condition that is false, and I have an or separating them, then if at least one of them is true, it's going to return true. So since condition 1 was true, we're going to return true. This does not check a condition per se, it just returns the opposite of the condition that you're given. So condition 1, we say it's true and we say not, it's going to return false. If this was already false and we put a not in front of it, it's going to return true. And now we're on to our comparison operators. So these are also useful for our conditions, but they do a little bit of math. We have greater than and less than, equal to, at least, no more than, and not equal to. So we have a couple examples here. If I have one variable or one value or one number, I use numbers for these examples to make it simpler. We can check if they meet these conditions. 8 is greater than 5, that returns true. 5 is not greater than 8, that's false. 8 is less than 5, that is false. 5 is less than 8, that's true. 5 is equal to 5, that's true. 5 is equal to 8, that's false. 8 is greater than or equal to 5, that's true. 5 is greater than or equal to 8, that's false. 5 is greater than or equal to 5, that's true. 8 is less than or equal to 5, that's false. 5 is less than or equal to 8, that's true. 5 is greater than or equal to 5, that's true. 5 is not equal to, I made a mistake in typing here. Pretend this looks like this, with the exclamation point and an equal sign. 5 is not equal to 5 is false, but 5 is not equal to 8 is true. And please stop me if you have any questions at any time, and I'm going a little fast. Alright, now we're on to augmented assignment operators. So sometimes we'll have code where we want to add to an existing value. So we have this letter A here, right, that I use in all my examples. And I want to provide some change to A. I want to add, I want to subtract, I want to multiply by it, I want to divide by it, something like that. So we have a faster way of writing anything that uses itself in the new declaration. So here we have A equals A plus B. So we can just say A plus equals B. So it's just going to add B to the existing value and reinitialize it like that. we can use that with pretty much all of these basic operands. So I can do a minus b, I can make that a minus equals b, a times b is just a times equals b, a divided by b, a divided equals b, a mod equals b. And this is just a faster way to write your code, because this can get annoying and it's harder to read. This is pretty easy to read. So you guys should use this in your code. And now we're on to the actual if statements that we were talking about before. So here we have the word if. We put a condition right next to it and we follow it by a colon. Don't forget this colon. That'll give you, if you forget it, it'll give you a syntax error, and this can be frustrating. So we have some condition here. We have x. If you guys remember what this is equals to 3. It's checking if x is equal to 3. And if x is equal to 3, it's going to print out x is equal to 3. However, if this is false, we're going to move on to the next if statement right here, this elif. Then if this isn't true, we're going to check if x is equal to 2. If x is equal to 2, then we're going to print that out. But if it's not, we're going to move to the next one, x is equal to 8. If it is, it's going to print this out. Otherwise, it's going to print out this last one, which is x is not equal to 3, 2, or 8. We can put any condition inside these and any code to do based on whatever condition it is. So I could do x equals 3 and something else, or I could do x equals 2 or x equals 5, something like that. Any condition I can put inside here, and I can change these bodies accordingly. And now we're on to some more complex structures like called loops. Our first one is a while loop, and what a while loop does is it tells a program to run until a goal is achieved, and that's called iteration. So while loops do something until a condition is met. So these are good for when something is indefinitely true. Like, let's say I want to, let's take an example from maybe just your life. Let's say I want to work until I want to work while I'm healthy. So there's going to be a while loop that checks while is healthy, continue to work, something like that. That's not actual code. That's just me giving an example. It's going to keep running indefinitely while that condition is true. Sometimes the conditions are true for only some time, like you know when they're going to end. For example, this condition, we have x equals 0, and we're running while x is less than 5, and then we're adding inside the body of the loop, we're adding 1 each time. So we know that this loop is only going to run that many times, 5 times. It's going to run 0, 1, 2, 3, 4. And it's going to print out this each time. But while loops are good when you don't know exactly when something's going to end. But you can also use them when you know when definitely something is going to end. For example, with this x. For loops are a little bit more specific. Usually you use them the way we used that while loop before, where you have an x and you're kind of you're incrementing it each time. And you know that that loop is going to run for a specific amount of times. We have this range x function that will spit out numbers in a range from 0 to x minus 1 in order. And we often use this for our for loops. So let's say we have for I in range 5. What this does is it's going to start from 0, and it's going to print out the numbers 0 through 4 each time. Usually you're not just going to be printing out numbers, you'll actually be using the value I in some sort of task inside of your loop. But this is just to teach you that this range function gives you the max number of iterations. Our range value can also be adjusted to a different range of numbers. You might not always want to start with 0 and go to that max number. You might want to start with the number 1, for example, and go to 5. So it gives you a range of numbers from x to y minus 1. So it does so range 1 through 5 is going to return these numbers 1 through 4. So remember, this is inclusive and this is exclusive. And we can also make this even more complicated by having a range x, y, z. So what this does is the same thing as the previous one. It gives you a range of numbers that are in between x and y, but instead of having a default step of 1, for example, in the other ones we had 0, 1, 2, 3, 4, or 1, 2, 3, 4, they were incrementing by 1. Here we can use z to tell it to skip count, sort of. It will, instead of incrementing by 1, we can increment by any number like 2, or even -1. We could count backwards if we wanted to. So here's an example we have here. We have 2, 5, and 2. So we're going to look for numbers between 2 and 5, and we're going to skip count by 2. So it's going to start with 2, and then it's going to print 4, but then 4 is less than 5, and you can't skip count by 2 after that, so it's going to stop. Then we also have our negative step over here, where we can start with a large number and go backward. So we start with 5, and then we go backwards until 0. And remember that our y is exclusive, so we're not getting to 0. We're only getting to 1. Is there any questions? I know that's a little bit complicated. Oh, sorry, I see one. All right, Sahil, you asked if indenting the lines of code matters more in Python than in JavaScript. I'm not too experienced with JavaScript, so I know that indenting, it shouldn't really be, it's not as, Python isn't as annoying as other languages about indenting, but it's still best practice to indent your code. For these for loops, it definitely matters. If you don't indent, it will not understand what you're saying. So here I have only one line of code inside of my for loop, but you see how I've indented it over here. This is so that the console knows that this statement is part of this for loop. If I stop indenting, it's not going to be part of the for loop anymore. So indenting does matter in this case. It doesn't always matter in all situations, but anytime you have a loop structure, like a for loop or a while loop or if statement, you definitely want to make sure you pay attention to indenting. The number that you can increment by a decimal. I actually have not tried that. We could, after we go over everything, I can run this kind of test to see. I don't think you normally increment by 0.5. I think you usually increment by whole numbers. I'm pretty sure I is an integer for our case. It's returning an integer. So I don't think you can use 0.5 right now. Is equal to 2 equal signs or 1. So when you're checking condition, you want to use 2 equal signs. When you use 1 equal sign, that's like you're initializing a variable. So let me type in the chat real quick. Name equals Elvira for number equals 2. When I use 1 equal sign, I'm declaring a variable. However, if I'm using num equals 2, I'm checking if the number is equal to 2. This would return so the 2 equal signs returns a Boolean, true or false, but the 1 equal sign is just for initializing a variable. Sorry, 1 second. Sorry about that. My mom was talking to me. Yeah, I'll get back into this. Right. So we were on for loops. Sometimes we can just use range to count iterations. For example, we're going to go from 0 to 3. That just gives us 0, 1, 2. But that number doesn't really matter to us. We're just using it to count a number of times. So I print out hi 3 times with this for loop. And Now what is useful to know is a keyword called break. So what break does is it's useful to check if another smaller condition is met inside of a loop, and we can end our loop prematurely if that condition is met. So here we have while x is less than 20. While x is less than 20, I want to make sure that we print out x and then we increment by 1. So it's going to keep going. So let's say I started with 0. Oh no, actually not. Yeah, start with 0. And I go in through this loop and I add 1. And I keep going. So I go 1, 2, 3, 4. But when I get to 4, I have this if statement right here. If x mod 4 is equal to 0, which is just asking you, is my number divisible by 4? It's going to add 1, and it's, oh, I click next. It's going to add, it's going to break if it's divisible by 4. So when I get to the number 4 in our for loop, our while loop, our code is going to break. It's going to stop running altogether. So I go from 0, I print 0, I'll add 1, 1, this isn't true, 1, 2, we go through here, 2 is less than 20, 2 mod 4 is not 0, so this doesn't run. It's going to print out 2, 3, 3 is less than 20, 3 is not divisible by 4, 3, 4, it's finally on 4, 4 is less than 20, but 4 divided by 4 is 0, so 4 divided by 4, the remainder is going to be 0 because it goes in perfectly. And so our code breaks. It's not going to, even though 4 is less than 20 and 5 less than 20, it normally would have continued. This is making our code break right here. So this condition, when it's met, it's going to break our code. Now we have basically we have a similar word called continue. It breaks the current iteration of the loop, but it doesn't break the overall loop itself. So here, when I get to number 4, when I get to 4 is less than 20, we're going to have 4 is divisible by 4, and we're going to add 1 in this one so that the code doesn't keep, so that the code doesn't get stuck being at 4. So we're going to have 4. It's going to become 5, and then it's going to continue. So it's not going to do the rest of the body of the while loop. It's going to not do this. It's going to skip this, and it's going to go back to the top. What this continue does is it stops the iteration here, but it doesn't stop the while loop itself. So it doesn't finish this code. It skips this and it goes back to the top. So when it gets to 4, it'll become 5, and then it'll go back to the top. It won't print out 5, and it won't become 6 over here. It'll just go back to the top. And then we have lists. Lists are fun. They are numerically ordered sets starting from the index 0. So they would go 0, 1, 2, 3, 4. We have a length of 4 in this list. And they contain any type of data inside of them. So to access any specific element from a list, you want to put the name of the list, some square brackets, and you want to put an index inside. So that index tells you the location of whatever element it is you're trying to access. So we have 0, 1, 2, 3, and 4. You would access them with that digit that I just said respectively. So if I want to print out this number 1, I would say 0. If I want to print out this oh no thing, I'll say the index is 2, because 0, 1, 2. We can also use negative indexes. That's what's really nice about Python. If you guys are familiar with Java, you don't have negative indexes. You have to do length minus whatever it is to get that index starting from the end, which can be annoying. Python is nice to you, and it's kind of it has this negative indexes stuff built in. So if I put -1, it's going to take our last one from the end of the list for you right there. Len list, what that does is it tells you the length of the list. You can just count how long this is. 1, 2, 3, 4, 5. This would return 5. And let me just check for some questions. Okay. So lists can be really useful for storing some type of data. So usually you won't have this kind of random numbers and like stuff like that. This is just an example. Usually in a list, you'll have some sort of similar data inside. So let's say I want to store data about the coronavirus, for example. I could store sorry. I could store someone's name, their age, their weight, their status on vaccination, stuff like that. And I could store all of that inside one list. And now we have list slicing. So this is where you want to return some range inside of a list. Let's say you have, let's take our coronavirus example. Let's say I have this huge database of information inside of a list. I have my age, my weight, everything. But I don't want all that information. I just want one set of information from that huge list. That's what this slicing is nice for. We can take a range and a step. So it's just like the slicing that we did with it's just like the thing we did with that range before. We have a start index, a stop, and a step. So let's say I have I could take any range like 0 to 5. I could skip count, or I could just put that as 1. The step one is optional, as if you remember. You could also use only a stop or only a start, or you could use this. What this does, it just gives you the copy of the full list. Also remember, the stop index is exclusive, just like it was in the range. This one, second parameter, always seems to be exclusive. So you'd get indexes from start to stop -1. I think I was talking about this before. If I use :stop, it'll give you, starting from the beginning, everything until that stop index, exclusive. And if I use this start, it's going to start at some point and then give you everything until the end of the list. And that's inclusive of that start value. You can also use negative indexes, which is nice. And then we have list iteration. So let's say I want to use the values in a list, going through each value in a list. We want to use a for loop to do that. We have a set number of iterations. So what we do is for item in list. This in keyword is important. You can use this for strings too, I'm pretty sure. What you can do is you have, let's say I have in my coronavirus data set, or my list, sorry. We have my name, my age, all that stuff, and I want to go through and print everything out. So it'll go through my list and print out each item that's there in that list. And it'll format it however I ask it to. This one isn't really formatted, so I just get a huge line of stuff, which we probably wouldn't want. But it'll print out everything in my list like this. And here it's a little bit more in depth about our membership operators. In checks if something is in another thing. Not in checks if something is not in another thing. So we were talking about checking if something is inside of a list. Sorry, we were talking about we were talking about the iteration before. Let me go back to it. For item in list, this goes through every item in list, but we can also use it as a condition. So if oh no is in my list, it'll print it out. If it's not in. So what's nice is you can check if something exists instead of a list here. You can also check if something doesn't exist in a list with that not in, which is just the opposite of in. So you can check if for is not in the list and do a condition based on that. And now we're on to identity operators. So we can check if two variables are stored in the same location in memory. And we can also check if they're not stored in the same location. So something to note is, in most programming languages, if you have two strings with the same text, the is operator is not going to return true. Those two variables are not, even though they are the exact same values, they are not stored in the same location in memory. So if I had two strings, I have name1 equals Elvira and name2 equals Elvira. They both contain Elvira. You would think they're both equivalent, right? They're equivalent strings. However, they're not stored in the same location in memory. They are not the same thing. The strings are stored in different locations in the console somewhere. And this is because strings are non-primitive types. That's important to remember. You don't have to worry too much at this time as beginners about what non-primitive means. Just remember that strings are non-primitive types, and so even if they have the same values inside, they are stored in different locations in memory. Primitive values, however, like integers, if duplicated, if like let's say I have a num1 equals 5 and num2 equals 5, they both contain the same value, but they're also stored in the same location in memory. Then there's also objects like lists. Any objects, you can assume that they're stored in different locations, even if they have the same value, because they are different objects. They are subject to change at any time, so they're not going to be stored in that same location. So I could have an object in Python like list, and that list could have the exact same contents. I could have list 1 with the coronavirus data and list 2 with the exact same coronavirus data. Those two, if I use this is, they would return false because they are not the same list. They are different lists, and they're subject to change at any time. Now, string manipulation. Strings are immutable, which means that when you reinitialize them, you're not changing the existing string for real. You're actually just redeclaring the whole thing. You're just changing what that variable is referencing. So if I set my name is equal to Elvira, and then I want to change what that name variable references. Let's say I want to change it to one of you guys. Let's see which one of you. I'll choose a random name from the audience list. Neil Lacerdo. If I say, actually my network's back. I said, if I want to change that name variable to Neil Lacerdo, I can just do that by saying name equals that. And that would change the point of reference in memory somewhere. The string Elvira still exists somewhere. It just stopped being called upon. Now, strings are like lists. They are characters in a set order. So what we want to do is we want to retrieve characters from a string the same way we retrieve elements from a list. So each letter in a string has an index. So in the name Elvira, the letter A is 0, and we go L is 1, V is 2, and so forth. All those characters have an index. And I can return them the same way I did from a list. So I can just take the name of the string and put either a start index and a stop index, or a start, stop, and step, or even just a stop. Pretty much the same way we did with the lists before. Let me go back to our lists here. You can do pretty much all of the same stuff with a string. And it'll just, instead of having each item in a list, it's taking each character from the string. And now this is my last slide for today, string methods and list methods. I didn't give too many examples because there's so many, but there are, on these two links, I'll put a link to them in the chat. Hold on. This is the first one, and this is the second one. These two lists contain a bunch of methods that you can use on your lists and your strings. For example, if you look at the reference table for stuff you can do to a list, you can append things to the end of a list, you can clear a list, you can copy a list, you can do a lot of things. There's a lot of things that you can use to manipulate a list that are already built into Python. And that's pretty much all I have for your introduction to Python. If you guys have any questions, just let me know. Otherwise, maybe we can do a couple examples on the topics that you guys are interested in. So do you guys have anything that specifically you want to see me show you how to use? For example, lists or strings. If that's not the case, we have 20 minutes left, so I'll find a quick example that we can run through that goes through a lot of the concepts we talked about today. Let me just open up a code real quick. Give me 1 minute. Oh yeah, by the way, all the stuff that I use in this slideshow is available in greater depth on codefortomorrow.org/Python beginner. It's where pretty much I got all my content from. It's a useful resource if you want to go over anything on your own. Let me just open up this in a REPL, and we can go over this example of string manipulation, the time we have left. All right, let me just switch the sharing. Okay, so with those methods that we were talking about before, let's say we want to use the upper method. What this code does is it asks a user to enter words over and over, and we have some methods that are gonna remove any white space, and then make sure that the word is only letters. We want to store those words in a list, and we want to ask the user for we want to stop asking the user for words when they enter an empty string. And we want to convert all the words in the list to uppercase and print the resulting list. And if the user just doesn't put anything at all, then we're going to print an empty list. So we have this starting list that is words, it's empty, and then while true, we want to just go through and ask for words. If word is empty, then if they input an empty string, we want to break. If the word is alpha, if you look at your reference, is alpha tells you if the characters are all strings in the alphabet. That's one of the methods that we can use on a string. If they're all alphabetical characters, we'll append it in uppercase to our words list right here. Append just adds it to the list, and upper makes that word that we got all uppercase. And if they give anything else, it's going to be error, please enter one word. And this is going to keep going until this is met. It's going to keep going until the person enters an empty string. And then it's going to print out words. So I can run this and show you these methods in action. So here, if I enter a word, let's say ball, cat, dog, beer, I don't know, 2 random words, and then I enter an empty string. When I enter the empty string, it broke. We used our break keyword that we learned about. And for all of these, what it did was I entered one real word. So it used the is alpha. It checked that they're alphabetical strings. And it appended them to our words array, and it made them uppercase. So we got all our words in uppercase. And that's the string methods. Oh, I see you guys have some topics. Strings and lists, that's what you guys want to go over. So I just went over the string methods. These are just some basic ones. Any methods like these ones that we can put at the end, let me just quickly run over a few important ones. Let me just share my screen to that now. Alright, so the string methods that there's a lot of these in the string. For example, isAlpha is here. This is one that we used right now. It returns true if all the characters in the string are in the alphabet. We can also have this format one. This one's really fun to use. It formats specified values in a string. You'll probably learn this later on. It's a more advanced one. We have find. It returns the position of where a specific part of a string is found. IsNumeric returns that the strings are numeric. That's important. IsDigit is also important. Returns that it's all digits. IsUpper tells you if it's all caps lock. Lower converts things to lowercase. And there's a bunch that you can look through here. Starts with's important. And upper, like the one that we used in our code, just converts it to uppercase. Title converts the first letter of each word in the string to uppercase. It's useful. Swap cases is also something you might use. If it's capital, it'll switch to lowercase. If it's lowercase, it'll switch to capital. And then before I do an example of the list ones, I'll go over the methods in that too. List methods. So we used append before. It adds an element to the end of the list. Clear, you can clear the elements. Copy, you can return a copy. Index, it returns the index of the first element with the specified value. Insert, you can add an element at a specific position. Pop just removes a specific position. Remove is remove something with a specific value. Reverse is just move the list over. And sort is sort the list. And you can play around with a lot of these at any time. You probably won't use all of them for now. Then, what's this question? Okay, if you put random values, can it order them in ascending order? So, I don't really use the sort method that much. I can check. Let's check actually real quick. Let me clear this. Let's say I have nums equals 1, 2. Share the rebel to answer that question. Sure. I'll fill this with some random numbers. And now I will do print nums.sort. I think I did that wrong. Nope, I did it right. Okay. And we'll see what that returns. None. Hold on, it's weird. I didn't use that correctly. Let me check how to use this. It sorts them by ascending by default, it says. I don't know why I didn't sort them. But it should sort them in ascending order when you use it properly. Let me figure out what I did. Let me actually use these as strings because the example it gave used strings. There you go. I don't think this is for integers, sorry. I'm supposed to be for strings. They used cars. What's that? Cars. This sorts it in alphabetical. Why does it keep saying none? To get rid of print. Alright, that's not doing anything there. Don't know why this is not working today. Oh, oops, wait. Sorry. I did something stupid here. There, now it printed it out in alphabetical order. It's ascending. Let me see if I change it to numbers. That works too. 1, 2, 3. And that's already, hold on. 8, 7, 6. And yeah, it goes in ascending order. So yeah, that's how you put them in ascending order. And any other questions? Because we got 10 minutes. Otherwise, I'll start some examples on lists that we can walk through. Okay, I'll get an example on lists. Just add into this. Okay. So our next one that we're going to go over is integer info. So we want to create a program that takes an integer as an input and creates a list with the following elements: number of digits, last digit, a true Boolean value if the number is even and false if odd. We want to print the list. So we have these examples that we can use. 1, 2, 3, 4, 5, 6 should print out 6, 6 true. That gives you the number of digits, that's 6. The last digit, which is also 6, and whether the number is even or odd. And this number ends with 6, so it's clearly even. This is basically a similar example. 9 digits, the last digit is 3, and it is odd, so it's false. So what we're doing here is we're taking an input, and remember that when we take an input, whenever we input, we're getting a string. So we have this int over here, and we're casting it to an integer type. So we're converting our string input into an integer. This is important, because we can't use strings in math calculations, like I said before. So I take my integer, and I turn that string into an int. Then I will use that int and compile it into a list with the respective information. So first I find the length of the number that I inputted. So I take len of a string that is num. So I have to convert. Len takes in a string input, so I have to cast our integer that we got here back into a string. So I can use this len command to find how many digits are inside. Then our second thing, we want to check the last digit. So it's taking mod 10 of any number returns its last digit. And the last thing that we want to take into our list is whether that number is even or odd. So to check if a number is even or odd, we just know that we have to check if it's divisible by 2, right? So if something is divisible by 2, the remainder should be 0 when you divide it by 2. So we can use our mod function here and say if the number is divisible by 2, then it'll be true. Otherwise, it'll be false. And that gives us all these conditions that we want to put inside of our list. So here, I'll run this, and we can try our example here. 1, 2, 3, 4, 5, 6. That's true, because it's 6 digits, which we get from this len stir num. 6, because when we do all of this mod 10, Dividing this by 10 would give us a remainder of 6, and so that's our last digit. And then when we divide this number by 2, we get a remainder of 0, and so we get it true from this statement, which just means that it's an even number. My favorite thing to do in Python, honestly, I'm not sure, but I like lists a lot. I think manipulating lists is fun. I use Java a lot more, so I don't use Python as much. But that's probably just because of school. We only got 4 minutes left, so I'm not going to start on an example, but if you guys have any questions, I can quickly answer them. Otherwise, I'll give you guys that link to more in-depth where I got all this stuff from, in case you're. In what ways is Java similar to Python? So they're both programming languages. They both are object. You guys can define objects in both of them. They both have methods where you can divide functions. Lists are really similar to array lists in Java. They're both used for different things. I wouldn't use them I feel like I wouldn't use Python for objects, to be honest. Is Java used more in college? Well, I'm a high school student, so I'm not really the person to ask that question, but I feel like it would depend on what classes you take. But yeah, it depends on what classes you take, I would say. If you take classes that are Java, then you're obviously going to use Java more. Um, I know at least for high school, most AP Comp Sci is going to be in Java, so you wouldn't really use Python. I think Principles has Python though. And yeah, that's all I have for you guys though today. So if you have any other questions, feel free to stick around and ask. But otherwise, you guys are good to go. Also, before you go though, Proof told me to let you know that there was supposed to be originally a webinar today at 1 p.m. for how HS Navigator works and its features. That webinar has been moved to Sunday, August 8th, 12 p.m. It is no longer today. So just letting you guys know about that. Do you have to write out code on paper in AP Comp Sci? So if you take the in-person exam, which is the normal way it's done, you do have to write out code on paper. Is there still a lesson after this webinar? No, there's nothing at 1 p.m. today. The PowerPoint? Yeah, of course. I'll show that PowerPoint right now. Right. There's the PowerPoint. In case you needed it. Nope. Do you know how we can access all the PowerPoints on the HS Navigator website? I'm not sure yet. I know that Meher is going to be taking all our PowerPoints and compiling them onto one spot for everyone. So when he compiles them all onto the website, we'll probably send an email or something to all of you and let you guys know. But everything will be made available to everyone on our website at some point. All right, if there's any more questions, I'd quickly ask, but it is 1 p.m., so you guys are free to go. No problem. All right, I don't think there's any more questions, so I'm just going to stop recording. And thank you guys all for coming. I hope you guys learned something.